evaluating the limit can be a bit difficult when there's a sum in the middle. But here I will introduce a couple of tricks to help you solve this type of problem. So we already know that we need to get rid of these i's in some form. We either need to get rid of them immediately, or we need to get rid of what's it called? We need to replace them with n's, for example, because we're taking n tends to infinity. So that is the trick. So here I'll introduce something that's called the partial fraction decomposition. Before that, I'll just very briefly write this as just the fraction. I'll write the fraction as I times I plus 1. Now I claim by this partial fraction decomposition thingy that 1 over I times I plus 1 can be written as something that's divisible, that's divided by I, and another thing which I don't really know, but it's going to be divided by I plus 1. This is my claim. I don't know what the values for A and B are, but if we have them, that will be very nice, and we will see how in a given moment. But at least from this look, we have something that's nicer, because A and B are constants, and we will find the values for them in a moment. But also because instead of dealing with this looks more friendly. Just divide by I, or if you're just dividing by I plus 1. Now, if this is true, if you assume that this is true, then it would also be true if I just multiply both sides of the equation by I times I plus 1. I hope you don't mind. In that case, on the left hand side I'll get a 1 because it cancels out, right? Now for the first term I'll get a coefficient of I plus 1 because the other one cancels out, the I. And for the second one I'll get a coefficient of I. B times I. Now this is equal to 1. Okay, what does this tell us? If A and B are constants, then it is good practice to compare the coefficients. Before I do anything, I want to write this expanded form of the bracket plus A plus B. Color coding is very important. Then I have these two as common factors. I'll factor them in. So I'll write A plus B, and then we have a factor of I. But then on the side we have an A, which is on its own. It's this one. Now this is equal to 1. So that is the trick here. Well, actually that's the first trick. We're still going to talk about another trick. That's another thing. Now 1, I can write 1 as 1 plus 0 times I. And now if I compare the coefficients, I find that I find two things actually. So the first thing is that A, which is the constant, will be equal to 1, and A plus B will be equal to 0. So if A is equal to 1 and A plus B is equal to 0, then B must be equal to minus 1. Okay, what does this mean? It means that A is 1 and B is minus 1. Yeah. Okay. Now, a good exercise is to check this. So you can multiply up and down by I here, and on the other fraction you can multiply by, for example, I plus 1 up and down, and you'll see that indeed these two are equal. Now, given that we have this expression, I'll now write down my sum. I won't write down my limit. I'll just write the sum. First thing is, we've established that this is equal to 1 plus I plus minus 1 over I plus 1. So that's already a good progress. Now I hope you don't mind if I write this as two sums. So the first sum would be of 1 over I, and the second sum would be of, well, it's negative. I'll put the minus here, and it's going to be 1 over I plus 1. And then let me ask you a question. How does this sum look like? It looks like 1 over 1 plus 1 over 2 plus 1 over 3 plus so on and so forth. Actually, until 1 over n, but we're taking n to infinity, so it's actually something like an infinite. It's finite for now. Okay? It's not an infinite sum right now because we haven't taken the limits. And what does this look like? Well, it looks as follows. So you just plug in 1, you get 1/2. Then you add 1/3, and then you add 1/4. But then what's going on here? Here's what's going on. We're taking a minus. So in theory, this should cancel out with these. But this will remain. That is the trick. How do you see this? Well, you need to explore a little bit. You need to play with the sequence. Make sure you understand what these two objects are so that you can draw interesting conclusions like this one. And now the question regarding how do you formally write this down? Well, here's how. So this is a sum from 1 to n of 1 over I. I will just expand the first term. So I'll plug in 1, and I'll start from I is equal to 2. There's no problem with that, right? Of 1 over I. I don't think there's any problem whatsoever with doing so. It gives you the same expression. I just expanded the very first term. Then what? Then I want you to notice that if I is starting from 2 here, and it's 1 over I can get the same result if I write this from I is equal to 1, and I write 1 plus I. That's the trick. That's the real trick that's going on here. So it's just a manipulation, so to say. And it is true, if you plug in 1 here, you get 1/2. If you remove this and you start from 2, then you also get half, and then a third, and so on. So we didn't really change anything. It's just a change of perspective, but it's the same expression because we still have the 1 here. Then notice that this expression is exactly the same one as that one, but it is negative, so they cancel out. And therefore, this whole thing is equal to 1. And therefore, the limit as n tends to infinity, maybe if I call this sum S, okay, if I call this sum S, then the limit as n tends to infinity of s, which depends on n, so it depends on n, so I'll call it Sn, is just, well, Sn is 1. So the limit as Sn goes to infinity, as n goes to infinity, is also 1. So that is the golden trick here. Now, what is, there's a terminology for this, the phenomenon that we've just seen, and it is precisely given by the following. So it's called a telescopic sum. It's like a telescope. I don't know how it would resemble a property of the telescope, but in one sense, you're adding 1/2, and then you take 1/2, and then you add 1/3, then you take away 1/3, then you add 1/4, and then 1/4. So I presume that is what a telescopic sum should entail. So maybe I'll write it down. Now, what is telescopic? It's Sn. And that is enough for this question. For different questions of this type, you should definitely watch out for telescopic sums, because this is a very complicated way of writing 1. You know, if they do all the numbering, like 1, 2, 3, 4 in this format, I think it will be very difficult to comprehend. But we can try using these techniques and ideas. And if we do the following for this case here, then 1 should be the answer.